Welcome to Zuluba Consultants. In this video, we want to look at how we calculate the number of moles, the number of molecules, and indeed the number of atoms when we have been given the mass of a molecule. Do not forget to subscribe to our YouTube channel and the Facebook page, that is Zuluba Consultants, for this and more videos. The question reads, in 15.7 grams of water, calculate the number of moles. So for us to calculate the number of moles, we need to use this formula, where we say number of moles is equal to mass divided by the molar mass. The unit for number of moles is mole. The unit for mass is grams, while the unit for molar mass is grams per mole. After we know this, we need to get some information regarding our question. So let's get some information. The first one is the mass. The mass that we have in the question is 15.7 grams. After we have the mass, we need to get the mixture for water. Now, for us to get the mixture for water, we look at the water molecule. Then we look at how many atoms of water are there. We have 1 multiplied by the relative atomic mass, which is 16. It gives us 16. Then for hydrogen, we have 2 atoms of hydrogen multiplied by 1, which gives us a 2. So this gives us a total of 18 when we add. So basically, we have 18 grams per mole as the molar mass. Now, if you have that as the molar mass, we can use the formula to calculate the number of moles. So the formula is number of moles is equal to mass divided by mixture. So the mass is 15.7 grams. Then the mixture is 18 grams per mole. This gives us the number of moles. So the number of moles will be 18 into 15.7. So when you calculate on your calculator 18 into 15.7, it should give you 0.872 moles. So this becomes the number of moles that is present in 15.7 grams of water. So we can put this figure as 0.872 moles as the number of moles we have calculated. Next, we want to calculate the number of molecules that are present in 15.7 grams of water. To calculate the number of molecules, we need to use the second formula, where we say number of particles, in this case number of molecules, is equal to the number of moles multiplied by the Avogadro's constant. So let's get some information for this question. The information that we have is, we need to have the number of moles which we calculated as 0.872 moles. Then we also have to have the Avogadro's constant. Now this number is a constant number, which is 6.02 times 10 to the power 23. And us who are chemists, we need to treasure this number and remember it by heart. So after knowing that, we will now say number of molecules is equal to the number of moles multiplied by the Avogadro's constant. So the number of molecules is equal to the number of moles is 0.872. We are multiplying this with 6.02 times 10 to the power 23. So if you get this and put it on your calculator, 0.872 multiplying it with 6.02 times 10 to the power 23, it should give you 5.25 times 10 to the power 23 molecules. So this becomes the number of molecules that are present in 15.7 grams of water. So we can put this number, we are saying 5.25 times 10 to the power 23 molecules. So these are the molecules present in the 15.7 grams of water. Last but not least, we want to know how to calculate the number of atoms present in the 15.7 grams of water. Now, for us to get the number of atoms, we need to understand how we calculated the number of molecules. So the 15.7 grams of water, we converted first that amount to the number of moles. Then the number of moles helped us to get the number of molecules that are present in this gram of water. Now, these grams that we have atoms. So when we look at the molecule of water, how many atoms are in the molecule of water? You realize that oxygen contributes 1 atom, then hydrogen contributes 2 atoms. In total, we have 3 atoms that are in water molecule. Now, if each molecule has 3 atoms, and we have 5.25 times 10 to the power 23 molecules, how many atoms then do we have? We are simply saying we need to multiply 3 by the number of molecules. So if we multiply 3 by the number of molecules, which is 5.25 times 10 to the power 23, we should get the number of atoms. The number of atoms. When we punch 3 multiplied by 5.25 times 10 to the power 23, we should get the number of atoms. The number of atoms as 1.58 times 10 to the power 24 atoms. So this becomes the number of atoms present in the 15.7 grams of water molecule.